Na gut. Dann wollen wir mal loslegen. Yeah, this is the last one with the easiest difficulty. I guess this is
Easy difficulty?
the easiest difficulty, 5.
Yeah. Some square.
Das ist nicht noch eine Maus. Na, nicht. Was war das mal? 6. Die Summe der Quadrate. Nee, Square Difference.
Läuft das aus die Nummer? Zahlenlänge?
Not quite sure.
Oh ja.
100
is it
is easy.
The sum of the squares of the first 10 was
no, it will not. It will not go out of the, because 1 to 100 is say is 100 times 50 around that, or 100 times 5,000 square. So it is never going out of the regular calculating.
Yeah, Python is.
You mean integers? Oh, okay.
Integers,
Yeah, I wouldn't worry about that, no.
Even sticking below.
I remember there is a formula for the first one, like the sums of integers. Then you can do just square. Like,
Yeah, the sum of the integers, but you can also just do it in a loop, and each time increment the plus sum and increment the square sum.
is something like this. The sum of integer from 1 to n.
Yeah,
is
and
n
plus 1 or n minus 1 through 2. I think it was n minus 1, wasn't it? I don't know. I don't. N plus 1. Okay, you're right.
And to the power of 2.
Is
done in one line.
Is that? Yep, that works. Now you fill in 101. Oh no, you need to do them all. So actually it is not efficient to do them. Find the difference between the sum of the squares of the first. Oh, the total sum of the squares and the squares of the sums.
That one minus the.
No, they mean the sum of the squares.
So the sum
They mean only for 1 to 100.
Okay, well, just this minus
101.
without the square. Yeah.
So this is the, I see. So this is the same as
Wait. If you change that 55 into 10 times 11.
Yeah, this is to the power of.
interesting.
What?
Well, this is 55 then, I suppose. Interesting. Well,
What?
well, no, okay.
That's not
No,
interesting
not
at all.
particularly.
No. Now do them all for 101. Both. Change to.
Yeah, the first one minus the second one.
Yeah, first get one and.
The range from 1 to 101.
Find the difference between the sum of the squares of the first 100. Okay, so the sum of these differences.
No, the sum of the squares.
We just need to do this.
Just
minus
modify
this
the
and
formula
we
and change the
range.
11 into 101.
Right, but the range is from
101.
well
1 to 100. Yeah.
well yeah, okay.
Yeah.
I think I understand. Okay, for I guess
No, just fill it in.
This minus this and we change the range. Maybe
but
you
that's
didn't-
not this is but isn't that this?
This is yeah, that is for 11. And now you modify it into 101.
Okay.
That one minus, yeah. And now you make both 101. And that's the outcome. Oh yeah, minus plus. Okay, 25.
Yeah, there's probably is this
Yeah, it is in the no, it is. It's just that the sum of the squares is less than the square of the sums. It's the other way around.
Okay, it's the other one around.
Oh, so we do we do the other way around. So it will be positive.
Okay, that was a good one.
Because it was so quick. Well, don't
I
count
don't know
your.
why it's even a good question.
We hope you have enjoyed solving this problem.
I think maybe with C we could have.
Let's see, you
But
have
if we
a lot
used
of
long and it will work.
you need and probably if you look at the blog, there is again a J programmer who made it in.
You want to see? Yeah.
Not interesting.
Let's take it.
This was a nice.
Warm up, I guess. No, just keep it, put it aside. So, but you could pick another one.
The middle one. Problem 89.
89? 90. Yeah.
Or 68. It's problem 68.
Oh no. I will not write something to convert Roman numerals. I will not. This has to be something a bit more interesting. If this is about converting Roman numerals, I will
Skip
Google. I will Google a program to do this. For a number written in Roman numerals to be considered valid, there's a basic course which must be followed from the requirements of some of the
There's always a best way.
Okay. Okay.
Roman.txt contains 1000 numbers written in valid but not necessarily minimal.
So, what do you think? You want to do this?
Can you
Just
show the
do
file?
mod and stuff. Mod 10 or 100. Just doing mod 10 converted to X.
Yeah.
It's very good.
Maybe.
You think you can glean something interesting out of it?
If it is not in the most efficient form, it is because there is, for example, 4 i's next to each other, which becomes IV.
Right.
No, it's too difficult, and then you need to do that in a row, because if there are 4 x's and then 4 i's, you need to do the.
We have like converted to int and then to write it properly. So we have 2 functions.
Yeah, you have
First
to convert it.
We convert it to a number.
Yeah,
Then we
and then back to
Yeah.
the most efficient one.
Mhm.
So you need a
Just
program on Google to convert these 1000 to numbers. And now we can also skip it.
Well,
Converting. Okay, that's nice. That's parse from a Roman number.
Well, we need that too, right?
Oh, it's two. There was return the number. Return the number represented by
Oh, this is a
a
placeholder.
subfolder, a sub function. Roman to numeral, and is there also a numeral to Roman? Yeah, you need them all. Also the the sub function, I think. Oh no, that was it. That was it. See, D I and 4I in range, and that's the other way around. That's more difficult.
What did he import?
No, let's just try this for start. So let's first of all save this where I can actually read it. What is it? I think it's in share.
Yeah.
B89.
Did you have it? Yeah. 89.
Oh,
Roman.
089.
Yeah.
Okay. Lines list, I guess, or strip. Actually, this works
Whoa.
easier if I probably do read and then split lines. I think this is the easiest.
Okay.
We can be.
What did you do?
Good. I pressed the wrong key combo so that all of a sudden everything.
Control Z.
No, just tab. Something with tab. With. So here should be lines. Here's some lines.
Yeah.
So I guess I need this super duper. Pick any one of these.
Let's read them. That is Roman to numerals.
Are you satisfied that this will work? I don't know. Let's just try it. I don't see anything with dev null or m.f syscall, so I'll just use
For
this.
each until total. Roman is a string. Length Roman, yeah.
So let's just try this.
I guess without. No, alright.
Let's just try something simple.
No, it is alright, I saw it.
How do you know?
Yeah, I can read the Roman numbers too.
That quickly?
Yeah.
Okay. Now we need.
Maybe we can like test if we have four eyes or 4 1.
Oh yeah, try one. Just
Because
do
It's
V
already-
I.
I mean, to test it, like.
But this converts it to a number, so it's not.
Yeah, I see.
We need to convert it back to the string.
Yeah.
I don't know. Maybe this is available in Python somewhere.
Yeah, that was the other. There were a few further.
No, I mean built-in, but maybe it's not. Python to Roman.
Yeah, it was already.
Roman numerals.
Where is package?
I don't feel like pip installing anything at the moment, to be honest. Int to Roman. Well, if you must.
Yeah, more common than lines.
Well, it's also input stuff. I don't need. Oh, this is not input. Okay, I understand correctly. Let's see. Okay, let's see. This is Python 2.5.
Argument is wrong.
We
does
don't
not-
care about this.
It does not go over. Oh no, it doesn't go over.
This is also incorrectly indented, I think. Yes. So this is.
CP.
Yeah. I'm not sure, this is may or may not be a benefit in Python. Now I have to care about the indent.
Yeah.
in C or whatever you wouldn't, but you would have the bad indent. You would nobody would stand for it anyway.
Here's there's 3 spaces.
I think.
What is the difference between 7 spaces and 2 tabs? What is then precedence? It always
difference-
sees a tab as 4 spaces.
What the fuck?
What was it saying? Just pick another one then.
Well, I think I have it now. So.
It's a 9. It's a 4. Yeah. Yeah, indeed, it's only with a 9 and a 4.
You think
Indeed.
are there no other special cases to make things smaller?
No.
But they may be doing stuff like this. Maybe is there something larger? No, there's nothing larger than M. But
No.
CCC. Could this not be expressed as
Yeah.
CD
I think it would be the same.
like this?
That's all right. So that's a 4. CD is 400.
Right. And this isn't this?
That's 8. And if there is another C, then it's 9, and then it becomes XM again.
I see.
And with the L the same.
L is 50
Yeah.
and C is 100.
And C is 100. Yeah.
The
Cent.
And
C for cent.
M and
cent.
CM will not work. Probably not.
CM, yeah, MCM. That's you know the movies.
Yeah,
all,
yeah.
MCM, LXXX. That's
Yeah.
1980.
So this can
No,
be expressed as CM, can't it?
Yeah. No. That's only 3 C's. That's 800.
Okay, can it be?
Cannot
okay,
be
it's only one
abbreviated.
C.
It's
That's
only one that can be skipped. Yeah.
fair enough. But okay, but it's conceivable that somewhere in this file there is a DCCC, isn't there? 4 C's.
Yeah. That's the case of it's a 9 here, because you already have the correct number. So actually, if this
is he working through the bases? Or because this
Yeah.
reads to me like it's only for V and X and so forth. Or is it? Or does it also handle the D and C and whatnot?
The next character is 2 away from.
Well, it is indexing into nums.
I don't
I think
believe
he-
the guy.
I think it is indexing into nums, so we should be able to. Well, we can make a simple unit test. We can convert to
Yeah,
number
there-
and back to Roman and back to number and back to Roman.
Yeah.
Well, actually, one back to number is enough.
Do 1994
1994.
if the function.
What's the name? Int to Roman. 1994. Did I not press enter? I suppose not. Not before the issue was there. Can't multiply sequence by non-int type float. What is a float? Who is putting a float somewhere? It's doing here.
Is this Python?
Yes, it is. It's Python 2. This is 94?
Yep.
Mm. I will assume so.
So it is 3 times the smaller before a bigger one. You see the MCM,
Yeah.
and then the
Yeah.
XC is 90, and then the IV is 4.
Okay, for line in lines.
I don't like it anymore. You need to count all characters also. Don't forget, because the question is how many characters will you save?
Yeah, well, that's, I guess, not the worst.
Oh, there's another thing. If they're all correct, you can only do some saving in. Oh no.
So this should be the case. Num should be equal to and back. That's interesting. So what not?
What was the thing? Assert.
Yeah, this is it raises this error if this condition is not true. So this converted to a number is that, and if we convert that to, wait a minute, did I get it wrong way? Roman to int. No, I have it right. It's Roman to int first. Then I have,
of course you need.
and then back to Roman. Doesn't have to be the same, but
MV. Oh, there is. That is totally wrong.
so who has the issue? The other guy,
Yeah.
the first guy.
What was his outcome? MVD. What is that? The V is 5. Before a 500, that is not allowed.
Yeah. Okay, then we look for another solution.
That was the right one.
Really?
That
No.
Roman to int was alright.
Yeah, Roman to int was all right.
Yes,
No,
into
wait,
Roman.
what? No.
Yeah, Roman to int was alright. That was it for. What was it? 4, 6, 7, 2. Yeah.
Oh, okay, fair enough. Okay.
And now do it again. Into Roman for 4, 6, 7, 2. Yeah. Yeah, it's wrong.
Okay. Then I suppose.
That was the problem for it's a 4. He forgot to check if it is 4 amps. You cannot do that. It's a 4.
I think this is
an easier one. Yeah.
Let's try just this.
Tuple?
Tuple? What?
What's the name? Tuple zip. What is that?
Tuple is a Python data. It's kind of like a list, but it's not appendable. You can't append to it. You can't.
And why zip?
Zip means give me each of these elements pairwise. So take one element from here and match it together with this one and so forth. I can just print this thing for you. So here you see they've been zipped together, so to speak. It's like you go through here and you get each pair.
Yeah. Nothing to do with zip as.
No, not compression.
As raar.
No.
As bzip.
Zip as in the zipper.
Yeah.
Okay, so this passed apparently.
Try. Where?
It's okay.
Yeah, that's better.
Should be still the same.
Yeah.
Okay, which means we can now calc the savings. So this is the len of our line, which should be longer, minus the int to Roman length.
Now you do them all 2 times. You can also. That's all right. Okay. Try it. I assume it is alright. Oh, yeah, congratulations.
Yeah, we can Google
Next.
Yeah,
anything.
exercise in googling your.
Yeah, well, I guess we could do something like
Yeah,
if
yeah,
we wanted to learn a new language.
No, wait. Can you go one time more? There was something
Oh, in the forum.
question. No, in the there, that one.
What? This
That
one.
one, yeah. You see what he sees? I replaced all D, CCCC by CM.
Yeah.
Counted 3.
Yeah. And looked at the
3 win position, 3 wins for 43 substitutions. Then CCCC leaving becomes CD, and so on. So that is very.
Yeah, he assumes that it's given the numbers ordered, but if it's not ordered, so it wouldn't work.
They will not order, but you have to take the largest combination first, the DCCCC, that becomes XM or CM, and
What if there is CX, then C, then X, then C, not then
no,
M?
they were. It was given that they are all valid. So
Okay, so I do what? I replace, let's say,
D with 4 C's first.
D with 4 C's. Every D with 4 C's.
Yeah, D for DCCCC.
Okay.
No, not now. DCCCC replaced by CM. 4 C's.
Ah.
What if
You have the total file length somewhere on the screen now.
Not yet, but I could look at the file.
43 matches. That was all right. Yeah.
What if he
But this
gives
is
one
just
of
me.
the C's not in order? So
No,
you cannot
it was
use-
given that they were all valid numbers. That they
Yeah.
were all
Okay.
written in a valid notation only, not the most efficient notation.
Ah,
We could look at, I guess, where is this? So I don't need this, I don't need this. I can do, what is it? Better.
What are you going to do?
I just want to get the files.
AWK or what?
No, just
The
the
VI.
just the file size, which should be this. It should be 9,800. shouldn't it?
Oh, is there not an editor which indicates your total characters?
Maybe, but
Oh, yeah.
you can also do W-C, which should be the same.
It's just in Windows, the notepad also indicates the number
I
of.
think also
I'm not
in
sure, it-
PyCharm is there.
Are you sure it I know that editors indicate number of lines or that, but I don't necessarily.
Or you do it in Word. In Microsoft Word, it
Well,
is
in any
also
case, so I replace all of these. I have
That's
the
43. There was 43 replacements.
right. Sure.
Now you do the remaining elements times of 4 C's. That will be CD. And then you do so without the D in the front, and you replace them by.
Okay. So DC by CM.
And then there's 4 C's. The remaining occurrences of 4 C's, they become CD. And then you see, then there's LXXXX, that's the 90, becomes XC.
This becomes CD.
Yeah. And then continue the 90 becomes XC, that's 48 times 48 occurrences. Yeah, 48 matches. True. And then you have the remaining 4 x's by XL, yeah. 47, yeah, was true. And then the 9th VII
So we
by
should do
IX.
them in order.
Yeah,
Yeah,
you
yeah,
have to
yeah.
start at the biggest one.
Yeah.
You first have to do the 9s and then the 4s, because if you have 4 C's with the D in front,
Sum up
Yeah.
up to that.
What was it? Just the 4 I's.
and that's again 53. Yeah, 53 times 2 wins.
So, and then
Now
we
you
have this.
And
Well, I guess.
the win is 743, and that's true. That was your. You want to let the computer calculate 9849 minus 9106?
Sure. Why not?
Yeah, you see, you can also fill it in on Google site. On the Google.
CPC.
Is this a problem? Oh, this is another solution. Yeah. Go down if you find the guy with the J solution again.
Yeah.
Yeah, there he is. Oh, that's more than
APA.
that's more than a one-liner. Ah, he does the whole conversion into number and the whole conversion back. That's not necessary. So
Yeah.
We should code next time with APA.
Roman from decimal. Jesus Christ. I don't know.
stupid language. Oh, this is not readable. It's just like AWK. You know that?
Yeah. Well, it's not as bad as that.
No, but
You know brainfuck language? There is a language called brain.
Well, I think brainfuck is probably easier.
yeah, this is totally brain fucked.
Yeah, I think you need a lot more brain power to decipher this
Yeah.
than the 4 instructions. In brainfuck, you'll always have a piece of paper next to yourself so you know where stuff is. Yeah, okay. So, Atef, please.
96.
You want to have this back in the...
Just one.
Oh, super.
Shall I write 743 at the bottom?
No.
You remember that?
No, it's now that I've started putting the problems into this account on project, so I have this logged in as EulerHack. Now I think it's okay. I think I'll just post in the other ones.
Sudoku, that's my favorite
Really?
puzzle.
Yeah, well, okay.
I'm at the moment at number 47 of very hard.
Okay. Well, okay.
What is the latest difficulty? Very hard.
No, there is 2 more or 3 more.
Oh.
There is extremely hard, and there is
There are also ambiguous ones, aren't there?
these are still not ambiguous, and the nice thing about this app is that the guy has done the levels according to the number of the order of tricks that you need
Yeah.
to know to find the solution.
Yeah.
And the very hards go until the trick that you have to combine, say, at least 4 fields with 3 different numbers and go around and then find that there is, after some, you have to find the way where there is, after logically filling them in,
Yeah.
there is one inconsistency somewhere.
Yeah.
And
Then go back and change from the beginning.
that's you have to just find the pattern where you can see the inconsistency, So you have to just look for
Yeah.
the pattern of say 7, 8, 9 here and 7, 8 there and 9, 8
Like
there
look
and
more steps ahead, yeah.
yeah,
It's-
and then
it's-
the extremely hard is to do multiple steps.
Yeah.
That you have 3, 4 combinations of these, and then I don't do that.
It's
I just find out the
Yeah, at some point you need a pen and paper to
Yeah.
memorize what you did there.
oh no, the app can perfectly set a bookmark, or you can go
Put
back
more
back
than
back
one
back
number
back.
in one case.
Yeah, the pencil things. So the possible numbers that can fit in this field, and then it's hint, and then on the as the last step it circles the 9 and the 9 and the 9 and then the 8, 8, 8 and the 7, 7, 7 and then you'll see the wing popping up, but of course you have to find it yourself. That's the what was the problem?
Yeah.
What
I suppose I'll leave this formatting
Super.
until later.
is the puzzle? Yeah, because who invented a similar and much more difficult puzzle idea called Latin squares. Replace the blanks in a 9x9 grid such that each row is. Oh, we just did a well-constructed Sudoku puzzle, a unique solution that can be solved by logic, although it might be necessary to employ guessing tests.
So Euler invented the similar one? Interesting.
Who invented what?
Leonard Euler, so it's a Japanese.
Yeah, Euler invented the Latin squares. That is, that's a super difficult one. I don't even know the details on it. Complexity of solution. 6K text file, Sudoku.txt contains 50 different Sudoku puzzles ranging in different unique solutions. By solving all 50 puzzles, find the sum of the 3-digit numbers found in the top left corner.
I think he might have come up with this. Isn't this basically what you're doing when you're solving for an unknown? You're trying to, you can build this matrix of, you have multiple versions that are for the same formula, and you can, if you build a matrix with each value, you can fill out the blanks. Isn't this? I don't know.
Yeah.
Maybe no. Okay.
No, you have to solve them. But there is lots of Sudoku solving algorithms, and probably also one in Python. I would say skip it. There's also a fill-in, so you can fill in, but it's only manually. Maybe there is a way to find some Sudoku solving code anywhere in Google. Yeah, you want one? Try Sudoku solver.
So you don't want to solve this?
No, actually not,
Okay.
because it's just Sudoku solving. You have to solve 50 puzzles, so of course you have to do it automatically.
Well, okay.
In this program you can fill in your Sudoku and let the thing solve it too. But
Well, even if I solve it, most of the time will probably be spent
hey,
in
you
parsing.
have a solving.
I have a solving.
No, this is just an algorithm for solving.
I can just Google problem 96 if that's what we're looking for, because most of the time will probably be spent here with parsing the pseudocode text and making it, massaging it so that our solver parses it.
And try and look for problem 96.
Okay.
I just Python Sudoku. Oh,
I don't know, maybe we can just leave this one for... I think we should leave this and
do it
revisit
another
it
time.
at some point. Maybe when we're... So I'm thinking maybe we can...
This one.
A simple Sudoku solver.
Alright. When we...
You need the extra pages.
We can put it in there.
Yeah.
For example, we might want to learn a different language rather, so we're focusing more on the language rather than the math problem. Maybe at some point. Then this is something that we could do then. I don't know, something like Elm or Elixir.
I like this. I like this Jupyter thing.
Yeah,
What was
sure.
it?
It's pretty cool, yeah.
Yeah, that's
But-
cool. That's the coolest thing I've seen in years.
Okay.
Middle one. 288.
288.
You can
An enormous factorial.
whoa, that's any prime.
For any-
This is the ones that I need to solve. That is if we can solve these by the easily,
Yeah.
we can crack the RSA and
As
we can crack the RSA and the SSL and
most expensive country.
Yeah.
I heard there was recently a proof that P is in fact not equal NP.
What?
There's a proof about PNP that
PNP.
it's not.
Non-complete program?
Is that the one? That's not the one that was proven by that Russian guy that denied the 1 million that was awarded.
Yeah. Poincaré.
I don't think anybody awarded anything yet.
Yeah,
No, there
the
was
Mathematical
one
Institute
for
of
Then it's a different problem.
Poincaré. It's
Poincaré.
not related like to be solved with
oh no, the
prime
PNP is
text,
not the Poincaré.
something.
The Poincaré conjecture, that is
Millennium
conjecture.
Prize.
Huh?
It was one of the Millennium Prize.
Yeah, but the Russian guy who solved it was totally in the press last year and
But he refused the
refused the 1 million
Yeah.
because he said that he read the basic principle of what he actually extended to that Poincaré problem. He read that in another article from someone else, and he found that other guy had actually earned the prize because he had done the basic digging work to find out some principles.
So the other guy got the money?
No,
No.
the Russian guy was awarded the money, and he
But you can give
refused
it on to him.
Yeah, if you're normal people, but if you are such a brilliant mathematician, you're not normal people anymore.
Okay.
I think it's stupid to
I wonder how long he spent on it. Did he spend a long time on this particular problem?
No, it was just some. Yeah, he has a job at the university, but he's not really a professor. Also, he was just teacher at some Russian university, or so, I don't know. Or not a
It's
student.
something related to surface and space. I think. The
And space.
Poincaré conjecture. It's not related to.
Yeah, but this
Small
not
geometry.
this PNP is not the PNP from the Millennium problem. The Poincaré.
Well, in any case.
Poincaré was very difficult.
There was something with
Closed spaces that is like.
in hyperspace.
Yeah.
There was the thing was they wanted to prove or not that a closed surface in a space is always a
space in one dimension less or something. Or in one dimension less, it is again a full space or something. I don't know it anymore.
Also,
Now I get to the.
I won't even begin to pretend that I understand.
Would someone have a charger?
USB-C? Ja, oder
Otherwise, I'll just I'll just don't open it anymore.
yeah.
That's better.
Okay. For any prime p, the number of npq is defined to be, or defined by, sum of So n equals 0 to q, and then t, where t n generated by the following random number generator. Fine. Times p to the power of n. Okay. It's not a random number generator, but okay, well, yes. Let n fac p factorial of np.
Oh, I would like to know the solution, but I cannot. We cannot find this.
Well, they're doing mod 20 of the factorial. This indicates to me that we don't actually have to calculate the full factorial. If we can mod it by 3 to the power of 20, right? Oh, we have to mod it by 61 to the power of 10. Fuck.
Yeah, you have to know that. What was it? What was the P and the Q? What is the Q then? The Q is
The Q is how far.
you do the summing.
Yes.
Yeah, one n is 0 to Q.
Yeah.
Of all n's as Tn is Sn mod P. Oh.
So we're doing the
Work
sum.
with squares, each time taking the square, and then mod 50550.
Oh wait, we're supposed to do 61. We're supposed to do 10 to the 7.
Now you see the random number generator. You need to
Yeah.
have that first.
Yes.
That is
Yes.
each time a square, taking the square, and then mod that probably is also
Prime.
a prime. Yeah.
No.
Okay, and that's nice. That helps. That helps. Take those two.
I need keep that.
That's the two factors of say if you know the RSA algorithm.
Yeah.
These two are squares. These two are primes, I
Yeah.
guess.
Yeah.
And the prime.
Does
two
this help?
primes?
Will this help us with the mod or anything like that?
Yes.
what's the relation
Yes.
between
Sure.
S0 and that one?
Because it's
What's the
You can-
relation between this number and this?
Not sure about this one. Let me just grab this.
just the starting algorithm is strange. No, it doesn't.
So this is also.
Yeah, but that does not matter. This is random. That
Yeah.
is a random generator. And
Yeah,
it
yeah.
starts, and the seed is at that 207,000,
Yes.
290,000. That's a seed. And
Right. This
and
is.
then there is each time a square,
Yes.
and you do mod that product of 2 primes,
Mm-hmm.
and then you mod it with p, and the p is 61 in our challenge.
Well, yes, correct.
The p is 61.
But that produces T, so Sn stays in between 0 and
61, but the the S stays between under that 50 million thing.
yes.
And then nfac be the factorial, and nf is the number of factors p in nfac. So you need to have the factorial of n pq.
That's the question. Do you need that? Because this is a sum of products. Well,
Yeah, the sum of powers.
and yeah, right. Powers also. Yeah.
Powers times the t.
Yeah, which is the number between 61 and 0 and 61.
Yeah.
Ah.
And that's and then the factorial of that. That means product of all until there. And then the number of factors in that factorial. The number of factors p. Oh, the number of factors p. So it's actually the power of p, that the highest power of p that occurs in that. And nf for 3, for p is 3 and 10,000.
The number of factors in
You
the
have to-
factorial.
you have to know your way in taking a mod of a high number.
Well, you can.
Yeah, you know, the mod of such a number is.
No, it doesn't matter. The mod of a product, a product of primes, is the mod of each of the numbers with each of the primes.
With
Or
what do you
something.
mean by with each of the primes?
Say if you have
A mod B times.
if you have 2 primes like 77,
Yeah.
711, and you have the 100 mod 77 is 23. If you now take the product of 100 times 100 is 10,000 mod 77. You can do the 100 mod 7 and the 100 mod 11 and
I think I need to write that down. 100 mod.
mod 77 is 23. Now do 100 mod 7 is true? No,
No.
not 3. 107. 98 is 2.
2. Okay, I trust you.
And 100 mod 11 is 99, is 1.
Right, yes. Mm-hmm.
And I don't know. Now you skipped the 11, so this is 2 times 11 and 1 times 7. No, it doesn't fit. There was a trick in these, and I don't know it anymore. There is a trick in a mod.
Well, you mean, okay, so I want to do the product of all of these? Is that the idea? No, I want to do this is trying to simplify something, isn't it?
Yeah.
So I'm trying to do,
Oh no, it's
I'm doing the mod of, okay, let's say we have, I'm doing the mod of 77, that's the idea, right?
The mod 77 of 100.
Mod 77 of 100, okay, so yes, and the way, okay, so the split is here. You want to do the mod 7 and the mod 11 of this, and somehow you want to have this produce 23. Is that the idea?
Yeah.
Okay.
I don't know anymore how that was. Is it 2 times 7 plus 11?
I think
No.
you can do it the way around. You can, like, from this you can take the mod and do for 7 it will be, for example, you want from 100.
Yeah.
You can do it from this
Yeah,
and get the same result.
Yeah, this is also 23
Mod 7.
models. This is also 23.
23 mod 11.
Yeah.
I think this is what you mean.
Oh yeah.
The way around, yeah.
And is that useful?
I'm not
Sure,
sure.
but I don't even understand what's needed. The second one, let NF_PQ be the number of factors P in NF.
Well, they say
Number of factors. What is the number of factors?
Factors NF3 in the number of factors P. I think this is impossible.
Wait a minute.
Let's find the solution and look it up how people solved it. because I find it interesting, but we won't get.
Well, you know,
this.
yeah,
Let's
sure.
understand at least
Yes,
the problem.
let's
before
understand the
we see
problem,
it.
and we have.
Yeah,
I don't know.
you can program it, of course.
If you understand.
It's only
I don't think this is.
Q
solvable.
is 10 to the 7th.
Yeah.
That's 10 million.
Yes.
That's maybe a bit much to let the
Do you
computer
know what
run.
does mean find NF? Of that?
The NF is the number of factors P.
What is the number of factors P? What does it mean?
If you divide the factorial, the n fac, by p,
So
how many times can you do that? No, how many times?
Yeah. So if you do the factoring of that number, no, not the factorial, but the put it back into
Division,
prime factors,
yeah.
then it's which power does the P have in that? So 61 to the 7th plus times of course times 47 to the 15th.
But in this case, they're doing 61 as p, right? So they're asking how many times does 61, and 61 is a prime, I presume?
Yeah.
This is the same p, right? They wouldn't be, they're not saying we want the number of prime factors. They're saying specifically p.
Yeah.
Yeah, not the number of prime factors, but the number of
Factors P.
the power that exists in the factoring for the number P. So
I see.
you do the
Yeah,
prime factoring
Yeah,
as
I see.
7 to the 2nd, 11 to the 4th, and so prime factoring, and then the power that is in the
For
P.
example, you have like 20 equal 2 to the power of 2 multiplied by 5. For example, P is 2 and we are looking for this.
Are you sure? Because
If we like make n fact pq to the like prime, make it prime factors, we are looking to the power of p. Because you can have prime factors with powers. So we are looking to the total power.
No, I'm not convinced.
But
I won't say I understand it.
You
so
have
well.
a factorial of, you just first determine a number n that is a huge number because that does a summing of 0 to 61 of this huge number times
I don't understand this.
you get
I mean, at least they give this as example to verify that the understanding is correct.
yeah, but for 3
Would you say that this makes sense? This what is it?
3 and 10,000.
624,900,000. Do you think that makes sense in context of this?
So this is P here is 3 to the power of
P is 3 in this case.
and this is for this case here to the power of this 9 multiplied by other numbers would be
As a factorial.
as a factorial of this sum
Yeah.
and to factorial of this sum, which is equal to
Yeah, but there is a problem.
to the 1
That t is really a sort of random number.
Tn
Well,
3 to the power of
maybe it isn't. Maybe it isn't.
and something like this. The solution is you given this nf, which is this. This is nf for the given example. If we multiply it by the other number of prime factors and do the factor of that, and this is equal to this npq, which is the sum.
Sorry, lost me.
Mod 61 to the 10th.
Oh, so if
Ah.
we computed,
I have a nice thing.
if we computed this, I think,
Yeah.
and do it to the power of factorial,
Yeah.
like
That I think that
Yeah,
part up
yeah.
to there I understand. I
Yes.
think.
I have a better idea.
Wait, let him finish.
if this was the question until here, find this. The question is finding this number.
Well, this is the NFAC, right? This is
Yeah.
NFAC.
So we should compute what's the power of 3. This is what we should do this to prime factors, and the answer would be 3 to the power of
3 to the power of the number of prime factors.
Yeah.
Where on earth do you read that? I don't
Yeah.
read that out of this.
No,
The number
it's
of factors P.
P. It's
The number of factors P. How is that? What?
Can you-
how
can
does
you-
that mean that?
I can like maybe more explain.
I think this is a textual thing. I understand. So you're saying we factorize NF? No, you say we factorize NFAC.
Yes.
This is NFAC.
This
You
is
factorize this into prime factors,
Yes.
and you take however many, the number of prime factors, and use that as the power of 3. Right, 3 to the power of the number of prime factors. That's what I understood. No?
So this could be factorized to prime factors.
Right.
Which one of them is 3?
Right.
And 3 would have a power, because factorization would
What
start
power?
with.
How
So
are you
the-
saying how often 3 is in? Yeah.
That's
Okay.
what I meant by, for example, 20. If
Right.
we
So here it's
factorize
2
it,
times 2
yeah.
times 5.
yeah, for example, P would be 2, and we are looking to the 2.
Now I
But
understand.
now we get to
Yeah.
something else.
This does seem a plausible reading. Okay, fair enough.
If you have a factorial of
Maybe if we write the example.
Yeah, but
in the
no,
code,
but-
we can.
No, but
Let's
this
think
is
about
interesting.
something-
Yeah. So when we do the factorial here,
Yeah.
we don't actually do the factorial.
No.
Probably. We only
No.
need to know how often the 3 occurs in it. Or the 61 as this
yeah,
case.
but that's clear. You take the logarithm, and you have the number of trees.
Logarithm base 61.
Yeah, but here, for example, you have a number that is say 10,000. No, wait, and say n is, so for that nf 3, 10,000, let's say the n number was 1,000,000. Then the n fac is the factorial of 1,000,000. So 1,000,000 factorial.
Yeah.
And then you need the number of factors 3 in that 1,000,000.
Yeah.
What's the number of factors 3 in 1,000,000? No, in that 1,000,000 factored.
Yeah.
That is, of course,
Well, in the factorial, million factorial
that is, of course,
factor.
the number of multiples of 3 occurring,
Some-
and plus the squares of 3 plus the higher powers of 3.
Yeah.
All just counted. That's
Yeah, going from 1 to 100. and counting them.
yeah.
Going
Yeah.
from 1 to 100 because the factorial is
Yeah.
like.
so.
I just have to-
Do it with
yeah,
smaller
and do
numbers. If you
some.
have the n was 10 as an outcome, and you
Yeah.
need the factors 3 in 10 faculty, you have, because 3 is a
Three
prime,
up, three
you
up,
have
yeah.
only have 3 and 6 and 9 that count along, and 9 counts double. So you're sure 10 factor has 4 factors 3 in it.
Yeah.
I'm sure.
I get the
I
approach.
don't.
I get
See, you get one for the 3, one for the 6, and 2 for the 9,
Yes.
and no other ones. So
But it's just going like a sum and count.
yeah, but it's difficult because you don't have that number, that n number. How do you calculate that n number? You need to.
This
Do you
n
need to
equal to
calculate that
0.
n number?
10 to the power of 7.
There's no way to count back from this 10 to the power of 7.
But we only but we don't have to count all of them, do we? Can't we go by steps of 61? So we are only counting at most
Yeah, we should
10 to the
do
6 divided by 2 approximately. So 500,000, something like that, numbers. We only have to do in steps of 61, don't we?
That's
here we
a
have
Q number. Yeah, of course.
Here we have a series.
No, it's a sum. So you need
No,
to.
we have a series number, so like from n to the 10 to the power of 7, and we should compute all the terms.
Yeah, and the total
And,
sum.
to do the sum of them, and then we don't need to do the factorial because it's clear how we can deal with it. But the
Yeah.
percent is
Finding
we
the-
should compute exactly what's
Yeah, we
n
do
equal-
need N. NPQ, we do need that.
Yes, I think that
And-
the
Okay,
starting point.
let's start there, yes.
Mhm.
And PQ.
Do we have
But
an
now-
optimization of this?
Yeah, that's that modding and so. But maybe Python does it super efficient if you use.
Something
Well,
like
this is all fits into 32-bit integer, I think.
Yep.
So I can
It keeps fitting because
I can do this in
It's
C.
very simple. It's something like
not 32,
sum
64.
at first.
even.
Yeah, sum equal to 0. Then we do loop from 1 to 10 to the power of 7, and then s plus.
Yeah, all pluses.
Yeah, maybe at first we take this 2, 9. This is 0, and then we do s to the
But
power of
Well, if
the
you
old one. Yeah.
Yeah, you find in S you do the power of you do it log p, then you have log.
I think it's just
You do it
repeated 10 to the power 7 times.
So if you
and
do
added
10 log 3, the 3 log of 10 is 2 and a little bit. And how do you get from 2 and a little bit to the number of the 3 and the 6 and the 9 double? It's difficult.
Talking about the next step, when we already counted the NPQ, or
Yeah.
okay.
Say the n PQ for 3 was 100.
yes. So
What
we
is
do
then the
from 100. I think it would be bigger than 100 because
Yeah, no, true,
100
but
mod 61 is
yeah, true. But just to get an example, you
okay. Let's
for
assume
100
B
you
is 3 and we have 100.
yeah.
Is bigger.
Then you have 3
from
and
3 to the range from 3 to 100.
yeah, so that is from
And
3
then-
to 99. That's 33 times already. And then the squares, that's still 9, 18, etc. That's still 10 times or 11. Yeah, also until 99. That's 11 more. And then the third power, 27, still 27 and 81. Also do count. So you have 33 and the 9 and 11 is 44 and the 2 of the 27 and 81. So 44,
Think you go
46.
for each number
So you-
from 3 to 99 and
So for 100,
divide it by 3 and count.
yeah. So for 100 you get for 3, and n is 100, you get to 46. And now how do you get the 3 log of 100 and then get to that 46? It's difficult. The 3 log of 100 is
We don't have to
Is-
use log.
is 3 to the 4th, comma very little bit, 4.1 or so, I guess 4.2.
I think we go from each number from 3 to 100 and divide it by 3 and check the result. That's it. We check the result and add.
There's something else. You know what also is wrong?
Let's maybe solve
They
this.
did an NF3, 10,000, and they say the outcome is mod 3 to the 20th is that big number. That means that there is at least more than 3 to the power of 20 threes in that thing, and then still 6, 2, 4, 9, 5, 5, 2, 8, 5 more. Is that usable, that knowledge? Don't do power 2, do times Sn. Do Sn times Sn.
because that's much quicker in. I think Python would do it automatically, but
Well, this isn't Python anymore. This
yes, Python.
Yes.
Why?
Or I guess long. Because I'm assuming it's not going to be fast.
Yeah. Okay.
I'm not sure. Just,
And S0, yeah.
Let me just check if Python long.
A long is a.
So they have ulong, I suppose.
Nah, long is unsigned. That doesn't matter. Long is long, or unsigned or signed. That's only a factor 2.
Okay.
But I don't think this is not particularly what I wanted.
No, you want the max int.
I just want to know what a long is called.
Yeah. Say max.
Okay, I'll just say long.
I think we completely.
Just do long. Long is 64-bit.
Presumably, yeah.
It's not coloring, but that doesn't matter.
Okay, so tn, I suppose. Actually, this is used only. Yeah, this is okay. Sn is also a long.
No, tn is also summed.
Right, but this is used later.
Oh no, tn is not summed. It's true.
This is also, it's all just temporary.
I think it's just one loop, so it
Yeah, the n in the end.
complexity
So the result is.
could be even with simple Python at work.
Well, I'm not so sure when we get to this
Yeah,
that will be the case.
Just do the result in the end.
Okay, so we want to start with this, I suppose.
You don't have the result yet.
Yeah. So this formula has been
Summing.
completely broken by this. Okay, so it's just this tn times p to the power of n. So this is at least, let's try and give an attempt. So let's see, this is also
P. You need to do cdef pn too.
okay, so wait a minute. What are we doing? We're doing
pn is p to the power.
but
of
we're
n.
getting the, I guess, result. And this is always, they're always doing a sum, so we're starting at 0.
Yeah, but do a running variable on p to the power of n too. It's because in every n there is pn is pn times p. It's quicker than letting it calculate.
You
p
just
to
want
the
me
power of
to
n.
write, you want p to the power of n, and every time I just multiply by p?
Yeah.
Okay.
So pn starts with 1. Because n starts with 0.
Yes.
But
So I have to do it at the end.
Yeah.
Okay, so pn.
First do the summing. The result.
Times n. Okay, I'll just put this at the end.
Result is tn plus. No,
to
is
the power,
No, p times
to the power.
pn times p.
p. Yeah.
Right.
Or p times pn. Yeah, that's all right. That's star equal or not? Is it not quicker?
It doesn't matter.
No, it's anyway. The compiler will read that, of course.
I hope so. I think it's Jesus.
And now result plus is.
Okay, yes, exactly. Result plus equals pn, and this is times tn. Yeah. Is that it? And I suppose I have to actually do this.
tn is as in.
And then I just return res.
Yeah, but you see what the result is. What did you do?
I haven't done anything yet.
Don't do it.
I just compiled. At least it compiled.
Why?
Because
I thought it was going to be to the running out of just to run, let it run. See what happens. Overflow. Because the number in the thing is more than 3 to the 20th.
Yeah.
which one though?
That means more than 10 to the 10th.
We need even to do the factorial next to that number. So.
The result is that large? Jesus fucking.
It's more than 3 to the 20th.
Yeah.
It's a mod 3 to the 20th, so it is a multiple of
Oh.
3 to the 20th plus this 6 to 4.
Okay, but we know about the mod, so we can always do the mod for the res, can't we?
It's a sum.
We can just.
Yeah, you can sum.
I
Of
think
course,
so.
you can mod the sum too.
Yeah, I think so.
Each time.
Yeah.
Res is plus the mod. Yeah, what is 3 to the 20th?
I don't know.
Just fill it in.
I don't think it's too big.
Yeah, no, just do that. Yeah, works.
Max.
Yeah.
Res. I guess no. This we're not going to start with this.
Max res. Oh yeah, okay. Whoa,
Maybe you can do.
did it overflow?
Yeah. Okay, so
No, do it there. There, Tn times Pn in brackets percent max res. Or you can mod them both if Tn is becoming very big. Oh no, Tn is not going over
it might, but
over
this
50 million.
Maybe 3 to the power of 20 is already too large.
It goes over, yeah, so it is indeed,
I don't think so.
This
No.
is with Python, maybe it's not long.
But isn't that what he said?
yeah, but you don't have,
long.
yeah, dude. Ah,
This
what
is,
was now happening?
Python, no.
There is something else wrong.
You say this should be long?
Huh?
Really?
What is
I
long
think
long?
it's 64. I think he's.
Is there no int 64? What is long long?
I think that should be it.
I know lang lang, but not long long.
Maybe, okay, maybe Atef knows better Python than we do.
No, I'm sure.
Long long?
Okay. Python uses normal C syntax for types. Okay.
Yeah, indeed. Int is, oh there it is.
Answer.
Yeah. I don't see a bit.
Yeah, me neither.
Maxint,
Okay.
it's a maxint, the function maxint for a type is the maximum in C, so you can display it.
I'm not sure this is the case here.
Python does not have the maxint function.
I doubt it, but I suppose we can try. So we're saying, let's say max res, and you say there's a function maxint?
I think so, yeah. No, it is not, no, it is, it's not, undeclared name, not built in, okay.
Python type sizes.
Size of an integer. Size of is only 8 bits, 8 bytes. It's 64 bit.
But this is C.
That's 64 bit. That is alright. Should be alright.
Okay, well, in any case, it was not what we thought.
Oh, it was size of? Yeah.
Okay, can I do, that was something that they said.
But now,
Python type def. That was the thing, wasn't it? I guess wrong. This is where I got it. Type def. C type def. Yeah. Let's just do the following.
What do you do?
I'm trying to.
Then do you cdef mylong also, not ulong? Because ulong is built in again.
I don't think it's built in.
Oh, okay, give it one shot.
Not in Python. Okay.
What was it saying?
No, it's doing the same. Is not a type identifier. Did I not have this?
You have a long, but that long, what is that?
Can you go back? Yeah, you didn't the capital. You renamed it and you didn't change it.
Ah, right.
Space.
Ooh.
Did you run it?
Nope. Still overflow.
And where is the overflow?
I suppose.
What is n in that at that moment?
Well, I suppose I shouldn't trust this.
Yeah, but what is long?
You want to actually see the value?
Now I want the size of long.
I think it's 64 bits.
But the regular long was already 64 bits. So what's the
apparently it's not.
Maybe it's for the minus. Long, just I'm not sure.
Oh, you think it's actually okay? Are we doing minus somewhere?
No.
Well, that's less source of error. Is it still?
Just type just append some string with one dot or so that can you at the moment of overflow you can still find variables or not with catch or try catch or
I suppose.
How that work the same? Can you comment the first?
because I'm curious about the variable how far does it get. Try it with 100 instead of 3 instead of 10,000. See how far you get. Oh.
Which one would you want?
Yeah,
to
that
do?
one, 1000, try. And 100. And 10. Whoa. Oh, it's the SN. It's the SN. Oh!
Did I not type the?
No, SN is squared and then mod 50.
But there's also no. I don't think it's the SN.
And then mod P.
Can I do the mod before first? No.
Yeah.
Can I?
No, because you won't get the SN for the next run, the next loop. But the SN is not the thing. Which line is going wrong?
39.
No, I mean which line in this in the loop?
Right. Pn times p.
It's like doing factorial of P39 factorial. Because we are doing
The print, yeah, that one is going out. That one is, and you can mod that too, of course. Pn times p
Right.
and max res.
Yeah. Okay, I probably remove this print. Was it?
Yeah, and now 10,000.
I'm surprised it got finished last time.
That's not the right result.
Still same result.
Yeah.
Oh wait, did you max res 3 to the 20th?
Yeah.
And what was when you did 1000?
No, 1000.
It's the same number.
Yeah.
So what's happening?
It's a good question.
300
That was the same.
and 10? So it's not changing anymore.
Yeah.
Is that a property of this calculation? That it is not changing above the square or above the...
Let me think. Well, we're starting low enough, so I guess we can print. What else do we now want?
and res, of course.
Yeah. Let's do it before this.
Why? Oh yeah, of course. That is preparation for the next one.
Okay, so at some point it isn't changing anymore, yes.
Oh wait, or at some point it is not. It is less changing than before. Say it's.
So n is still well, obviously n is still changing.
Now see, it is, see, there is a few times in a row. You go up. See, there's a 4 million, the 40 million thing occurs 3 times, and before that there is 28577 also occurring a few times.
I don't see it.
And then I mean the end, the res thing, and then it's always 0. See, the pn thing. What is the fourth variable? That's 0. This one.
Pn.
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 There cannot be. Oh, Pn gets to a whole mod max res gets to a whole times max res. Huh? It's not possible. And once you are on
Pn is a multiple
of max res, you are at 0.
Yeah.
And it stays 0.
Is that?
That is because it's a random generator actually. So you always get to within 60,
But we don't
61.
but the random generator doesn't touch this. Pn isn't touched by the random generator. It's the other way around.
I got it.
What was Pn?
So we are doing, I think we should get 0 at 20 because we are doing mod 3 to the power of 20 mod to the power of 20. So if you go to the 20, at 20 it will be 0. Yeah, that's what we.
This is, yeah, okay.
Because we are doing this,
I have
Yeah.
to.
and max res is en to the power of 20. At 20th iteration, this 2 would be equal, so this would be 0.
Yep.
And how did you get to that?
P is 3. If we just multiply, and max res is 3 to the power of 20. So at some point, 3.
So after 20,
Yeah.
after 20, you sure have all.
You have it equal, so.
Right, but this has to be a misunderstanding of how this function works, isn't it?
No. Now you have 61 and you do mod 61 to the 10th. That means after 10 times at least, you get to a 0 in the res.
So it does not change anymore.
But maybe we're misunderstanding that. Maybe this isn't true. Maybe we can't do this.
No, we should compute the
You can do that.
factorial of that number first.
We have to of the p to the power of n.
Yeah, this factorial, and then that should be this.
Right. Yes.
Yeah.
So this
we
is
didn't do the factorial yet.
yeah. So we can't do
That
this.
would be correct.
So you cannot do that?
No, it's okay, I think.
Yeah.
I think. Yeah, but what you
Because-
say the factorial? What do you mean?
You mean the result that we got is not equal to this? And what? Because nf mod 3 to the power of 20 should equal to that result, not the n.
Let me just remove it for now.
Ah, we are not at.
We are not doing the
Where is the
factorial.
NF? You don't have the NF.
Not yet. No.
We are they're only calculating. So the rest is the N.
Yes.
Yeah.
We should do the factorial.
Okay. And this is also.
But the N is not changing anymore after.
Yeah.
Okay. Let's do also res.
Oh no, wait. The mod is not changing anymore. If you take the mod of N, but not the mod of NF, that can maybe that changes still.
Let's just do it without. So these are just going to be.
Name it res N. That is res
Why?
N. So we need to calculate the result res NF.
Okay.
No,
But
maybe
that's
we
just the
can have a
factorial.
function.
You mean there's going to be a way to keep this?
I think it's not possible to calculate that factorial number of. Can you go down?
Yeah, of course you can take that along in the loop.
Yeah, we should do the.
Okay, but do we agree that it maybe makes sense to first see if we can reproduce this number?
Yes.
Yeah, there was something else. I
No,
need
but-
to
but
leave
that
it in a
for
quarter of
in
an
a-
hour. So
This number is resulted by nf, not n.
Right.
Yeah, so maybe we can make function now to calculate nf.
Okay, do you want to do this base in this loop?
No, maybe we can have another function.
Okay, which actually does the
Def
factorial?
nf, yes. No, not doing the factorial, but calculate.
no, it's you cannot do the whole factorial.
But we can do mod 20. The mod 20 is valid for while we're calculating the factorial, right? We can do multiply each time, right? We have to do so whatever this number is, we do the factorial. It's just 1 to the number to this number n, and we can mod each time our result. Right?
Yeah, there is a little problem. This number, that end result,
Yeah.
find NF 61, a huge number of summings,
Yeah.
mod a number that does not fit in long even,
Is that true?
because this is 61 to the 10th is around 10 to the 15th or so, 16th. 61 to the 10th. It just fits.
Yeah. It just fits.
It just fits. Yeah.
It's midnight. It's going all right.
So it just fits. But you need to keep modding, because otherwise
yes.
it won't fit anymore.
Yes, we need to do million. No.
So what's the mod?
10 million.
That is if you have n in the end, res.
We just have to go
Yeah, but you
from
cannot-
n to
you
up.
cannot-
We could count up to n multiply each time and mod each time.
Yeah, but you cannot mod n in beforehand because then you're missing out a lot of numbers.
I think we just do a loop from 1 to the thing that we already calculated, and do the method where we sum the factors of 3 to the power. Like, as you said, for example, we have 3 and 100. We go from 3 to 100, and for 3 it's 1. Then for 4 it's nothing. Then 6 it's 1 also. 9 is 2.
So you don't actually want to calculate this?
No. we don't.
Okay.
No, you just need to count the factors
Yeah.
Yeah. Of 3.
of where is 3? P.
Well, in this case,
Yeah, it's 3.
Yeah, but no, but in the procedure. In the
okay,
function.
but I think
So you can keep dividing by 3. No, you can. What can you do?
I still think it makes sense that we just do it for the smaller thing and calculate the actual value, because I think that fits perfectly, even with the multiplication. And then we can.
Yeah, just count the factors. But you can count the factors in.
Just so we can validate the solution in case it's actually a solution.
You anyway need to calculate n.
Yeah, we calculate that, that's clear.
Yes.
But how do is that working?
Well, who knows?
Give it a try. I think it's not coming in.
Yes, okay, so max res, we're going to stop with this, and we're going to stop with this.
What do you mean?
I don't, we
It's going into overflow.
Calculate n which.
well, I made it into a long, so it's going to be slow, but it will work, maybe.
No.
But we can't, but didn't we just,
No, then
Did we just
it did
see-
get to 39, and now with long it will get to 78. And
yeah, it will get pretty big. But I'm not
you
sure it
never
will.
get to 10,000.
Okay, but did we say it was valid even to do the mod by 20?
No.
For Pn it certainly wasn't. Are we saying it's valid for this? Are we saying it's valid for this?
For the result, it is not. I think for
Then it's not. Then it's not valid for either.
Pn it could be.
No, at least that's what Artef tells me.
You mean doing the mod max? It would also, because if we do the mod 3 to the power of 10 of the sum would be the same. If we do it at the end or for the result, in every step or for the result.
I'm going to pretend that I have infinite memory, and we shall see.
Try.
There. No problem. No problem.
No problem. And now,
We should
what is that long? Is that an
Is it beginned?
ah
64.
no big int. So string.
Arbitrary length. Is it just memory?
Long?
No, this.
Yeah.
It's 32. It's,
No, it's
Yeah,
string.
this is 64,
yeah.
and this is infinite.
Why would we remove the mod 3 to the power of 20? We should keep it because
Where? At which position?
here and here.
But you just did.
No.
Wasn't this the whole?
You cannot.
20.
Why?
But I have to leave. You cannot, because you have to do the factorial of this. To get the factorial of
This
this.
is your argument.
No, and
No, I said we should do next the factorial, but
oh no,
If
you
we
don't
do
have to
the-
do the factorial, but you have to
No, we
to
shouldn't
take the
calculate
number
the
of factors in the factorial.
yes. The thing is, we don't have to calculate the factorial, but at least we calculate n, not exactly, but also we are using the mod 3 to the power of 20. My argument is not calculate the number of factorials exactly. We just do your method to calculate the number of factors.
Can you type it in the end there? Mod 3 to the 20th.
Here.
No, after your formula. And here, mod 3 to the 20th.
I'm not sure what binds more.
Yeah, of course it's not the right number because you now need the factorial.
Oh, but wait a minute. This looks
But the
awful-
factorial of
this
the-
looks very familiar.
Yeah, the factorial of the mod is the same as the mod of the factorial.
This looks
True? No, that's not
Well,
true.
let me just-
Factorial of the mod is never the same as the mod of the factorial.
fascinating.
What problem is this?
This is a number. 288. But as it does seem that this is actually correct. So, oh no, this is not correct.
But I'm not
So this was correct.
Yeah, for the sum. Yeah, doing mod for a sum is not correct, but doing a mod for products it would be correct.
But I'm only doing the mod of this. I'm not doing the mod of the sum. I'm doing the
Yeah.
mod of this tn times pn.
Yeah. For the product, it
can also not be right.
But it's okay. I mean, it's still the sum is still the small, right?
Yeah.
Oh wait. How big is this? Oops. Maybe it's okay.
It will be the
Yeah. This is the actual sum. This is perfectly fine, actually.
Huh?
So now that number we should loop through it and calculate, check the prime
numbers of
factors and
three in
check
it.
some of the factors of 3
So
from
that's
3 to that number.
that's divide
one
by
leap.
3 plus divide by 9 plus divide by 81. Is it that?
Just going for 3 to that number and divide it to prime numbers. Yes. And then have functions that calculate the factor of 3.
Wait a minute. So I go for f as in factor in range 1 to n plus 1. So
Maybe P.
p factors 0 to start with, and then f mod p. Well, no, not mod p. Div, right? Is this no? This is the no. We have to get the factors. Okay, so we have to write a factorization
Yeah,
thing.
so that divide by 3 and you have the number of basic 3's.
It's like recursive way, you mean?
Yeah.
Maybe we can write it.
And then, yeah, recursively.
Yeah. Okay.
So,
Def.
no, it is not possible.
this was 200. Oh yeah, divide by 3 is of course this 624 million. That's almost
True.
Factors, it get the number and
No,
then
you're over 7 million already. 700 million.
Let me.
21,333. If you divide that by.
Where does this 20 come from? Is that a function of P or Q? No.
no.
No, they just took a random example.
Okay, so this is, I guess, has to be parameter.
Then it would be 10 or something.
Max res.
Okay, fine. Okay. So you want to... Should I iterate here, I guess?
The range P factors.
If we pass it a number and then 3 we calculate.
Just divide by 3. It's the P factors is 0. Now you say N2 is.
Yeah, if f mod p equals 0, call it again. Otherwise,
Yeah. Is there something?
return 0.
No, just divide that one time by. So N.
Yeah, it
N
will-
by 3.
NP something like that. F
Why n by 3?
Then you have the number of basic 3's.
But
something.
but that's only for the first thing, isn't it? I have to go through the whole, all the factor, I say, all the parts of the factorial, don't I?
F.
For each part of the factorial, we have.
No, you only need the factors 3, of course. So through P. So you do
Something
N.
like that. Return this if the n div p is n mod p is different to it is equal 0.
Yeah.
Otherwise, return like recursive return.
But this is the n. This is the n you're talking about.
Yeah, that's the n you start with.
Is the range.
No, this n is a different n.
This n is this n is f. Sorry.
Right, exactly. This is what I mean.
Yeah.
So you do factors of n comma p. Yeah. N comma p.
Well, he says f. You
No,
can fight.
n. You have n. So you by calling you need to use n. By calling first time you need to fill in n.
And
No,
p
not 4.
factors, plus.
No, you don't. You don't need to. You don't need to.
Everyone we.
You
No,
can type
you
if
don't.
you
You
want.
don't. You don't need them. What difficult. See. See.
Okay.
You have to go by.
You have. Yeah. You have 200.
Okay.
You want the factors of 200 faculty. And you want the number of factors 3 in it.
Yes.
You do 200 by 3.
Yes.
You get 66. Now you need the numbers of 9's in it, of course. You take that 66 through 3. You get 22.
And what?
And
But this isn't
then
the
you need the
factorial.
number of 81's in it, 27's in it. That is 22 over 3 is 7. Then you need the number of 81's in it. That's a 7 over 3.
But this is for
And you
200.
have- For example, you have the number of 3's in 200 faculty.
But this is all for 200, right? This is for 200.
Yeah,
Okay.
you see, there's 2 81's in it.
Why are there 2 81s? Really? You're saying this?
Because there's 81 and there's 162.
Can
So this
can
is
explain?
3 to the 4th, 3 to the 3rd, 3 squared. So what is the total number of factors 3 in 200 faculty? That is 66 plus 22 plus 7 plus 2.
Really?
Get it? The number of 3's, 66 3's in it. And then the number of 9's
How does that work?
is take the 66 and
You understand?
My approach was something like that. We have like 200 factorial would be 1 multiplied by 3 to 4.
Yeah.
200.
And you check each one.
Yeah. So for
So,
example, we
yeah.
start for 3.
Three,
Number
one.
of factors 1, and
Yeah.
then we have a sum plus
Yeah.
factors. So for example, for 1 and
Zero.
3, it would be sum 0.
Yeah.
Something like that.
So this is, yeah, but this is the obviously correct approach,
Yes.
but this is, I don't know, maybe it's correct, I don't know.
This is, you get the 3, the 6, the 9, the 12, etc. So that's already basically,
You mean the power of 3, not the 6. You are doing here
yeah,
3 to the power of 2,
Yeah, but
3, and so.
6 counts as 1 factor 3. And 12 also counts as 1 factor 3.
Yes.
The 9 counts as 2 factor 3, but we don't count it yet. We count the ones first, and then we divide again by 3, and you have the
So
ones
the
that
number,
call
you
9.
mean the number of 3 multiple of 3's are 66 in 200.
Yeah.
You mean like 3, 6. Yeah. No.
There are
And then you
66
take the
multiples
rest.
of 3. Then there are 22 multiples of 9.
Right.
Then there are 7 multiples of 27 underneath 200. And there are 2 multiples of 81 underneath 200.
But why the rest is the multiple of 9's?
But where's the 6, for example?
The 6 is included here. But
The 9 is
Yes,
because this
okay.
one, because you divide another time by 3, you get the number of 9's in it.
Oh yes, because 3 multiplied by 3 here.
Yeah.
It's 9. Yes.
Actually, you can each time start by 200 times 200 divided by 3, and then 200 divided by 9 is 22, and then 200 divided by 27 is 7, but you can also do it recursively. And I thought that you started with recursively because you meant this one.
I meant recursively we can solve the factors, the
Yeah.
function.
Are you sure we're not counting twice?
No, because you count this number each time one time.
Yeah.
So the 9 should be counted double, but you have it one time in the first time dividing by 3, and then another one.
Right, it should be counted double, but yeah, okay, it's counted separately, but yeah.
But you can,
One
you can
of the
try
three.
this. You can do 200 faculty divided by and try. No, you cannot. You can do both methods. But I have to leave.
Yeah. Cool.
I still don't really understand why the rest of here should be 3 9 plus.
Well, you mean the rest?
Why the rest of this division, like the mode, should be the
No,
the
it's
9
actually
powers.
because to get this 22, you actually have divided 200 by 9. One time by 3 and another
I
time
see.
by 3. You have to divide it by 9.
Yeah.
Yes. Right.
For getting the 7, you have to divide it by 27.
Yes.
Hasselwurst.
Try it if.
Okay.
Okay. Get rid of this.
Factors, yeah, just make one recursive function.
Yeah. Still, I guess up to
No,
n.
f comma p is alright. F comma. No, don't use the n. N is already a variable in the calling.
Who cares?
Yeah, f.
But it isn't. F is means factor. That's not what this is about.
No, it's a. You mean the count?
Yeah, this is our 200.
Yeah, but don't do it.
Yes.
Do an
Then
n.
it will be our big N.
It will be. Yeah,
Ah,
exactly.
like
This. Yeah, this one.
Okay. Yeah.
I think it's okay.
And why do you now do p comma n?
Because P is first. Every function has P as the first, so why change?
Okay.
Okay, so I guess will we start with rest?
Yeah. Result is 0. Yeah. res.
Well, this is the after we divide. We're going to divide by p every time.
Yeah, but you don't need the rest, you need the result.
Yes. Okay, fine. Yeah, we need that anyway. Okay, so in the loop, we're going to do well n
We do it recursively or
p remain, I guess.
No, remain is not necessary. Just
No.
res is res plus n over p. No, you need to have this running number
Yeah.
because you cannot. Yeah, just put
Something
another
like
variable.
call the same function, but
With
change the
different
bucket.
n, different n.
Just do an
The n
R1.
would be the n.
Okay. Then.
Oh, the n. Oh, you do the n. N is n over p, and then res is res plus n, while n is bigger than p.
Well,
While n is
Yeah.
bigger than p.
well, let's have if n greater p return 0, because we're recursing, we're going to return res plus.
Why be superior? I think the way around. The stop condition is the way around.
No, then you don't need to just do. No, not res plus. Then it's just.
This is
Maybe we should call it inside to not do the call before.
n plus factors
Like
p
that.
comma n. That is it.
Replace the n in the parameter.
Yeah, this is it.
no.
Yeah.
We don't have 200 factors of 3. Oh,
Wait,
right,
wait, wait,
because
wait.
I already divided by 3.
Yeah, and then you do the factors of 66, and then you get.
Then I do the factors of 66.
You have to do an else, of course. Otherwise,
Well, no, I don't think so.
Is
This isn't n.
oh no, he
The stop
returned.
condition is it? the
Yeah, yeah,
way
it's
around?
n. It's n. Of course, it's n.
Less than p. We stop.
Yeah, okay. But it's in. Yeah, okay.
This is it.
This is it?
And the rest can be removed. This is it, and 2 lines can be removed. And that one. Try.
No, the
Try
condition
200.
should be the way around. N less than p. We should stop.
Right, yeah.
yeah, you can
Yeah,
also
yeah.
do the
Very
other.
good, very
Yeah, this is the best one.
Super.
The least incorrect one. Okay.
Try. Function, try.
Okay. And we do NF.
No, just try factors 3,200 if the
Okay.
whether that is.
Did we have the value ahead of time?
Would be
Yeah.
4, 3, 2.
Yeah, try.
Would be 9.
I guess it is 88,
Oh, this.
2 times
88 and it's 92, 94. Okay. No,
94?
just let it calculate. Print.
Shouldn't be
Well,
9.
I want to no. You assume that we have the correct. We can calculate it. Then I assume that we can
I
know
assume-
it beforehand.
Yeah, 94.
94.
No.
Oh, you don't calculate the 2. 7.
88. Is this correct? 200 divided by 3 is 66. Yeah, that's correct.
Yeah.
This is correct.
Yeah. Yeah.
Oh, this is not correct.
Yeah, 66 divided by 3 is 22.
21 is the nearest.
Yes.
88. And 7 is 95. And 2 is 97. I just did the wrong add up.
Okay, so but then I. Are you sure? Well,
Eight.
why the 2? What do we want with the 2?
88 and 7 is 95.
2 is the 3. Yes, 2 is yes.
It was correct. The computer is more correct than us.
Okay.
Happens. Okay.
And now do the whole thing with That time. You have it there.
Maybe.
Now you can do the NF. Give it a try. That's not the right number.
Very well observed.
No, but it's not. No, but it's not. It's also a totally wrong number. Because 2133 million divided by 3 is
Shall I try mod
around
this anyway?
700 million. It's already too much because you only get 624 million. The 2133 number is too high.
This one?
Is too high. What is 3 times 3 up?
Oh, this is incorrect.
What is 3 high 20? What is? Can you show 3 high 20?
Yeah. Moment. 3 billion.
In 2133. I don't get it. I have to leave. It's not 10 o'clock.
Is this defeat?
There's a time budget.
But this is even more hardcore than I thought.
Yeah, this one is a fairly.
We skipped
Unbelievable.
Sudoku and we skipped Roman numerals more or less.
The Roman numerals thing I've seen, you cheated. Everything came from Google. I've seen it.
You watched the stream.
I watched the only one.
Okay. Danke fürs Kommen. Well, if you do, we'll keep it. Okay. Where did we go wrong? First of all, I thought we had the correct result for this stuff, which is a bit surprising now. Something went wrong.
I don't understand the problem, but if you run into overflows, then the numbers will be off.
I'm not running into overflows because C will actually complain if I do.
Good.
Okay, wait a minute. So if I do this, do I get the same result? Actually, mod. Okay. Maybe that was the issue. That looks better. Okay. Maybe this will... No. Okay, well at least it's correct again. I think I had the recalculation of the max res here for some reason. I'm not sure. Okay, so where did we go wrong? We're asking for the p factors in n, but we didn't do the factorial yet. Okay, this is not the factorials, this is the factorial factors, right?
Yeah.
Or nfac, I guess, if we want to be consistent with the names. Oh, and then we have to do nfac. So this is not even, and so this is nf. No. So nfac is not, that's not nfac. This is in fact nf. This is nf. Yeah, okay. Well, it's a recursive nf. Okay, so this is, I guess. I don't know. NF, I guess, some kind of internal helper thingamajig. Ah, and I renamed this. Okay. But I don't see the issue. We said we didn't have to do mod of this.
Maybe you are not calculating the n correctly.
Okay, well, I tell you what we can do. We can try and... no, you're saying the n is incorrect? But... Okay, but then it would have to be independent of this. Because this doesn't make a difference in the calculation. This was calculated without the mod, and then only applied afterward.
Yeah.
So
it would be the same result.
So this would be the same result, yes. So if this is wrong, then there's some other issue going on. And I don't know, this seems fairly straightforward. I can go through it, I guess. So we're going up to Q. I don't know, is Q inclusive? I think so. You don't have any... I think it's included too. Then we do Tn times p to the n, Tn times p to the n, and p is 1. And then we do p...
So maybe we should compute the Sn after doing the n.
We should do Sn...
After calculating t.
Because the first one is 0, right? That's a good point. So Tn, yes, fair enough. So no, down here, I guess.
Yeah, even before this wouldn't be a problem.
Right, yes, fair enough. We're only using Tn in this. Okay, that makes sense. Okay. Let me again just try this. And this is going to be exploded, so let me just do this. Yeah, okay. Doesn't make a difference. And now, it's still not the same. Willst du auch etwas beitragen?
I don't even understand the problem, but you're not using Sn.
I am.
Is this... okay.
Okay, let's just go through the... So Tn times p to the n. Pn is 1 to start with, which is p to the power of 0 should be 1, I'd say. So I think that seems correct.
Yeah.
Okay. Let's assume that they should have given an example of n. Did they give an example of n? No, I don't think they did. Just so... well, maybe that would be giving too much away. Because then we might assume that we have to know n to know the result. We could
not include Q so ein Stückchen. Wo ist denn dein S? Was ist ein Sn beim ersten Setting?
Very good point.
Das steht jetzt ja in hier.
Should be it should be S0. Adlerauge einsporn. Well, no, zu früh gefreut.
Ja.
I read the first 4 numbers and thought.
But this isn't off by 1 thing.
Sure thing.
Is it not?
I won't guarantee it, no, but maybe. Okay, yeah, we don't need S0 then, I guess. Do. Okay, well, now I'm willing to go over the stuff again, because if this was found, maybe there's more. So Sn, we do Sn to the power of, well, Sn squared, and not.
Es ist aber, warte mal kurz, da steht Sn hoch 2 Mod irgendwas, ne?
Mhm.
Wo ist denn das unten implementiert? Nee, weil das ist S. Ach doch, das ist Sn mal.
Yes. We could try and do the.
Oh, can quick start. Here, well, we have Tn is Sn mod P, but which one is P?
P is P.
P is 3, okay.
P
I
is,
thought we are using Sn mod Pn.
no,
Yeah.
no,
Oh,
not for this.
Mhm.
Zoom out a bit. Does that hurt?
It's okay.
Und das Range funktioniert so, wie man das denkt, ja? Das geht von 0 bis inklusive Q jetzt, oder wie?
Ja.
Achso, das wird Gibt es da einen Test dafür?
Leider nein. Leider nein. Also, die geben hier diesen Teil an als Beispiel. You are given that NF of 3 and 10,000 mod 3 to the 20 is this. That's what you're given.
And this
But
is what you get out of it also?
no, but this is N. So between N and NF there is more shenanigans going on. So NF is made by well, so it is said, I've been told, and it seemed plausible at least when I heard it, that NF is the number of factors of P, the occurrences of the factor P in the factorial of N.
And this is way over.
Yeah, I needed a quarter of an hour to understand all those parts too. So it's not, I think it's, do you know what factorial is?
Ja.
So,
Das ist die Summe aller
right.
Zahlen.
So the number of, so if you do up to, I don't know, let's do 1 times 2 times 3 times 4 times 5 times 6. So let's assume our P is 3. So then we want to know how many times does the prime factor P exist in this factorial. So it exists once here at the 3, and it exists twice and it exists another time here, because the factorization of 6 is 3 and 2. And so therefore we have in this set, we have 2 is our NF. That's at least what we think is going on. Of course, if maybe you read this differently, I don't know. Yeah, I think maybe the best we could do is verify that this works. No, we did verify that it works. At least for 3 and 200, which seemed very plausible.
Und dass das TN bei 1 anfängt, ist auch in Ordnung, ja? Das finden alle gut so.
Yes, because p to the power of 0, which is the first iteration in this sum, which is maybe easier to read here. P to the power of n equals 0 is 1. So yes, I think that's fair to, I don't think that's the issue. Artef, what do you think?
Couldn't find that could be the issue.
Do you have any way to verify this? Other than by hand? I'm just going to do crazy thing for a moment and think.
Was macht denn dieses Max-Fest da?
Oh, fuck. Okay. So this is the max. So we assume where is the so as we're going through here, we are always multiplying by p to the power of n, but outside we're using mod 3 to the 20. So this is the factorial of n. This is what this n factorial and nf be the number. Wait, sorry, no problem. Here n fac. Oh. Okay, maybe I understood something that's wrong, but let me just continue. The idea is that we don't actually need all of the, we only need up to a certain power. So we can just mod the intermediaries by 3 to the power of 20 and keep within our size of the integer. Because we, at the end of the day, we don't care about the other stuff. because we're taking mod 3 to the 20 of the number of factors. We're doing this wrong, Atef. I think we thought the mod applies to the factorial. It doesn't. It applies to the number of factors. Right? So we need the actual number of factors in the full factorial. So we have to know the full factorial, don't we? No, we don't. No, we don't.
We don't.
No, we don't. But we do need the... No, we don't need the full factorial, but we do need the correct n. We can't do without... We can't mod. We can't mod. At least, no, we can't do it this
But in F is the number of factorials. Is this correct?
Well, no.
What is in F?
This one?
No, yeah, but in above in the proper.
NF be the number of factors P. P being in our example case 3.
The number of
Should prove that
Ah,
n factorial
in
1
n
is equal.
fuck.
We should prove that n factorial mod 3 to the power of 20 is equal n mod 3, because we calculated this.
We calculated this, yes.
Yes, and we assumed that we didn't need to calculate the factorial, and we did
Yes.
but we didn't.
It may be that we don't have to, but it would have to be somewhere, I think, in combination with... I don't think we can split this up. Similarly with how we... No. Okay, well... Okay, so this is recursion error, so I think we can deal with this by just making this less recursive. Right. So this is just while and...
Okay, ich gehe.
Jo,
Ich wünsche euch noch viel Glück.
danke. Ciao. So this and so we do res plus equals n. Right. Do you want it side by side?
It should work that way also.
So this is recursive versus non-recursive. Yeah?
Yeah.
Okay. Okay. Not quite. Let's do our NF example was 3 and 200, which is not correct. Okay. So what did I do wrong? N less P res include add-on n.
Oh,
Oh,
I think the condition should be n bigger than p.
oh yeah. Greater equal, I guess.
Yeah. Should. Yes.
Yeah. Because it could be exactly 3. Okay.
Exactly 3, so it should be 1 plus 1.
Then okay, so this is some okay, so this is let's see. Okay,
This is without doing.
this is without doing the mod, so we're saying that this is maybe doing the mod produces our number.
Yeah,
Inconceivable.
correct. Nice. Yes.
Okay, well now I guess we just replace our numbers.
Why you would be wrong? What we changed from recursive to non-recursive?
Well, it was an overflow because there's lots of it's like a big int, right? It's huge. It's enormous.
Oh.
And therefore we have to do something non-recursive.
Yes.
Okay. So, what are the bets about this working with this? I don't know, to be honest.
At least we have a function with that value, so we can change
Yeah.
for the best.
Exactly. Yes. Yeah. It's a good baseline. Yeah. Okay. So let us just do the following. Let's just I don't know. So 61 mod 10. Yes. Should we include the mod in here? Technically no. Okay, technically no.
So we didn't include the mod in the n. We just did it in the factorial side.
We did not mod. No, we did not. Yes, we don't need it here. We don't need it here.
Just
Okay, 61 to the 10, and this is 61, and this is 10 to the 7. So let me just start at 4 and see if things go out of... Did I not? I didn't recompile. Okay, let's see if this goes... how fast it explodes. Okay, it's exploding pretty fast. Okay, then I suppose we do need to look at optimization. So, I
You
think
can do more there.
here, I don't know.
Oh, maybe because we already at the end we're gonna do 3 to the power of 20, we can do it to the prime factor. Can we do it there? for the previous test, but here we can do max res, the 3 to the power 20.
Okay. Well, just hard code for now. Did I actually? I didn't actually mod anything. Okay. I'd be surprised. What is the theory behind this?
I think because we already doing it at the end, if we do it before would be the same. Not sure.
Different.
It's different.
Yeah. I think we're going to have to pull these two together, because if we're going to do anything with max res, it's probably going to be somehow expanding all of this together. So if we think about, so this is the sum, no, it's a sum, it's a sum. It's a factorial of the sum. And I don't think that, I think that means pretty much that we can't say anything about the factors of the final thing. After we have to have the sum before we can even talk about its factors. Right?
I think we didn't calculate the NF at the end. We calculated NF mod 3 to the power of 20. So the real NF would be something less than 20. Because
What would be less than 20?
the NF, the number of factor of P, would be less than 20 because P to the power of that number would divide the n factor, PQ. So we have the NF is the number of factors of P in n factor.
Yeah.
That means P to the power of NF, P to the power of Q would be equal to that factorial.
P to the power of NF would be less than.
I mean P to the power of this multiplied by the other factors,
Sure.
yeah, would be equal to the n factor.
Sure.
Yeah. So now if we do this mod 3 to the power of 20,
Yeah.
are sure that NF
I think you may be onto something, yeah.
yes. So NF would be that factor multiplied by that like power of 3 multiplied by the other factors. So if I can write it,
P to the power of n times, I guess, other factors,
you mean this NF?
nf, right? Nf. So nf is
NF
of 3 and 20 in this case. And P is this. And
3 and Q, which no,
Oh, right, they say 3 and Q is
10,000.
oh, it's just 2Q.
Okay, fine. This one would equal to the n fac P and Q.
N fac, right, that's N fac. Yes, that's N fac P and Q.
So this
And now if we do this mod, I guess we call it max P or max. What's a max? Max. What do you name for it? Max res, I guess. Okay, let's call it. This is Pmax. No, is it Pmax? This is.
I'm sure that at some point the solution will be using some like logarithm because we are like playing with powers and because then we have something like NF multiplied by this other thing mod b to the power of 20 would equal to something.
Okay, but if I expand this, this is like 3 times 3 times 3, and somewhere over here there is the 2 that belongs to it. For example, this part, this is for the 6, and the other part of the other factor to produce 6 is the 2 over here. So the other factors are over here, right? 5, 7, whatever.
Yeah, it may not include 7, for example.
Right, yes, there are lots of other things, so this is the other factors.
And then what we do, then we take this NF and we do mod 3 to the power of 20. And this NF.
Yeah, this is
And we have the result. Whatever.
yeah, so you're saying that because of this we can assume what? So mod 3 to the 20. 3 to the 20.
Because this was, I was thinking that NF would be 3 to the power.
Well, there are going to be lots of 3's in here, right?
I mixed it. I thought this would be here, so mod 3 to the power of 20, and this is because we already multiplied with it, so NF would be this.
But this is NF. This is NFPQ, but this means that the thing we're asking for is this whole thing, mod 20, 3 to the 20. Does that not mean that we can,
This is 10 factorial.
No, this is number of factors. And fact is this thing, is this, yeah, it's this. Okay, pardon me. It's this. No, it's not. Fuck. Yeah, so this is no, this is n fact. Okay, yes, okay, I'm wrong.
What is the value here of NF? Did we?
I think we did. What is this one? Hold on. This is all n fact. No, this is correct. This is n fact. And we're not doing.
What is the number? This one. Command just one command after this. Command. Just want to value of NF.
The value of NF.
Yes. Without doing the math.
Okay, this will
It will be.
it will be meaninglessly big.
So it's 3 to the power of that number. It's very good.
Yeah. So the question is, so we want to have the number of p factors. Yeah. Okay. So so p n. So this is basically from here to here, right? This is the number of, this is, or let's say small nf, right? The number of elements here. Do they do to the power of p? No, it's just the number. So this is our small nf.
Very big.
Yes, but we know that we're going to do mod 3 to the 20 on it. So, does it make sense for me to keep around to actually calculate all of the things? Let's say that so this is the 23, so there's 3's down here. So let's say there's 53's here. Should I only keep 10 around? Do I only need 10 to care about the result? Because mod 3 to the 20.
I think this is like the sum of number of these, but here it's like multiplication.
Yeah. Okay. Yes, I'm doing mod of NF, not mod of one of these. Okay. God, deze job.
It's something that we have a number of that is
Okay, so logarithms is what you're saying.
not sure. There is relation between sums. I assume we're gonna use, because if we can have a system where we have, for example, 2 equations with 2 unknown things, we can use it to to find a solution. But here it's not that good use. And then because there was something to the power, so I said you probably would use the right.
Yeah.
So did we didn't calculate this?
No,
We don't know this.
we didn't calculate that, in fact, no.
Yeah. These both are unknown.
So I wonder if I'm even getting n.
I would like to use this. What is
I'm wondering, so on the one side we are blowing it.
So we couldn't calculate the NF for the other,
For the small example we have it.
but for the other one.
For the larger, no.
Yeah, the NF is the button.
Well, actually the NF, yeah, we have the NF for the smaller, yes. You mean the NF?
I mean the NF is the bottleneck, like we should try to resolve it without even
I'm not
have
sure.
to calculate the NF.
I'm not sure what the bottleneck is, to be honest. I can try and do time it of this.
Is this and or maybe this is the result?
Which?
This one.
No, this is for 10 to the 5 and not 10 to the 7. I aborted because... Okay, I can do maybe something larger. So this is NF, but we don't know how much. Let's do time it of n for the same thing and see how much of that. So this is 1/4. I don't know how much that tells us though. So most of the time, at least for these values, is spent here.
Yeah.
And n is getting smaller. So even assuming this can't be meaningful. Okay, let me just see if this is still distributed the same. I guess I can just let's just start off with this. Let's see. Maybe it's not the best approach to do it with the division. I don't know. Just based on, I don't know, what will be larger. So if you just look at it, it looks like it's O of n, but maybe the big int division makes it n squared. I don't know. No, but no, apparently not. It's just 1/4 more, basically. It's some smaller fraction. So most of the time is spent here, but still a significant amount here. I think, see, the int isn't that the Python integer? Apparently not.
Can we make rs be int?
Wow, sure.
It doesn't.
It's still pretty big. No, we can't. We can't.
What?
Well, you saw the size, right? Even for the 3 to the to thing, it's huge. This is res. Ah, oh no, or sorry, yes, you're right, but I think it's a different one, but it's still huge. So res is huge.
Oh. Yeah.
The problem is called enormous.
I think this was very optimized and very good solution. I think we can calculate the thing, but it's still big.
Ah, but we can do mod on this, can't we?
But it will be the same, or no?
I think we can. Well, I think we can at least. It won't be the bottleneck. It won't make much of a difference, but we can do the mod here, I think.
Right.
Yeah. So in this case, then we could do cdef int. I think we, well, maybe in long. Yeah. I won't try that. So Pn is ginormous. Yeah, well, maybe it doesn't hurt.
I think that wouldn't change the n, maybe nf would be improved.
Yeah, not much though.
We are calculating only once the n, so it would be okay.
So here we can actually pass that in. Should get the same thing. Type error, really?
Understand?
No. Oh, I did recompile. Yeah. If I didn't recompile, is this valid? Okay, so we have n, which is a big int, and we have p, which is a long.
We do a mod, the rest. So
Yeah,
if
this
this
is-
max res is long, so the
Yeah. Yeah, but it's doing, but since this is a big int, it's doing a mod on a big int.
we can, because we said nf anyway, it's very big.
But I think,
But we are doing the mod here. So
yes,
it's
we're doing
okay.
the mod here. Yes, if it's intelligent,
So this is the final result you mean.
yeah.
Yeah. Can we trigger it?
We did. It's down here. So this is for the 3 to the 20. But it's still not fast enough.
No, but this for n. But here we didn't launch it yet.
Yeah, but it's not going to be faster.
Why?
Well,
We did the mod.
okay, max res 61 to the, well, then now's the question how much we want. Well, actually, no, it doesn't matter. We can do 61 to the 10. That's fine. But it still won't get finished. Well, it will take a minute. It will take a minute. It won't get finished fast.
Right. We go faster because we just move the function up. And maybe we are calling this more, so it would be much, it would be slower. Because doing this at every step or doing it at the end, it would be the same.
It may be slower, yes.
Yeah.
I don't think it will make much of a difference either way, but it will, if it has an impact, it will be slower, yes. Although I don't know. Maybe the runtime depends on how big it does depend on how big the big int is. So we're doing mod on smaller numbers here.
Yeah.
So maybe it does make it faster. But either way, apparently not much.
I think so. I'm sure that this is bigger than
3 to the power of 20, I guess. So why not here instead the bottleneck is we have very big n number and we are doing like an every step just divided by 61. Why not start by doing it in chunks? Not in chunks, maybe we are sure that there is a big P that will sum up here, which is 61 to the power of 10. Because anyway there we have the rest is very big. So at that point we are making less loops in this thing.
I don't know if we can do less loops, but if we can get away from the big N, then you'll probably be fine. Took longer. So you're saying we always know we're dividing by 61. Okay, correct.
Yeah.
So can we do this ahead of time maybe? So we know, for example, that we don't. It's the same old problem. Well, actually, maybe it's not. Maybe it's not. Maybe it's not.
So if we start with so as we said, we have multiple threes, which here is 61, and there is other factors.
Yeah.
So if we take any big number, for example 61 to the power of 10 here. Yeah, so we start as res is res as 10. We initialized as 10 and we continue.
Reza is 10. 10 is what is that cube? No. Why 10?
This max res.
Okay. Okay, so you're trying to work in the powers, I guess?
Yeah, I want to reduce
Yeah.
that loop as
Okay.
much as possible because
Right.
and make res equal.
Okay, let's just think. Let's just think with 3 and 20.
Yes.
We can. So this is currently, as far as we're concerned, we could do log to the base 3, and then we would be just working with addition and subtraction.
Mm-hmm. Maybe sample change we can start with res equal to max size, and we time it, and then check if it's the same result or not.
Okay. Let's see.
I think this one wouldn't change. We only make improvements to the NF.
Yeah. Sorry.
Yeah.
Okay, this is still significant enough for us to use as measurement, I think.
Yeah, so
So you want to have this be 20, I guess?
yeah.
But this will of course change the result.
It's I think not true.
Why not? Of course it will. How could it not? It will be 20 larger. This will be 305.
Yeah. Well, I think is.
But I think instead, so if we think of n as being in base, so what is the log of n? That is kind of the question, I think. So math log n over math log of p. So this is n base p. Haha. Okay, I guess. So if we take this, can we do anything with this? Because this is working on this I think. Right. So this is I'm not the best with logarithms. So in base 3, just 3 is 1, I would say, isn't it? Because 3 to the power of no, it's not. It's 10.
If you want to multiply log to this,
Yeah.
it would be nt multiplied by log 3 plus this log this. So you can apply it here.
Yeah.
So log of n. That's one thing. Log to over this expression e to the power so this would be log e to the power of f plus log another factor and this equal
Right. Okay. Which means
if this number is not equal to, could we here always divide by p to the power of 2 and then multiply the rest by 2.
Why?
Because this would be like 3 multiplied by 3, and this is like the first thing. 3, this is, it's, for example, it's this nt would be like t multiplied by, let's call it p nt equal nt. So we should divide by this 3 to the power.
You're splitting it literally in 2.
Yes. But maybe we can like try bigger factors.
Yeah.
Because if we because this is would be like complexity of n, but if we try to try dividing with powers, so it would be complexity of logarithm of n, because we are reducing. I mean, but this, assuming the nt is multiplied, but if it's like prime number, so we can't do anything. It's just like this is assuming stuff, and here we are doing
I'm still thinking if we can do anything. Do you think that working with these logarithms may bear fruit, or no?
if it could be used to resolve the plot.
If we can work in just logarithm, then I think we may have a chance. Could it be that 3?
Yeah, at the moment I want to write something like this to maybe we can restart the system, but I don't see have any clue to.
You're trying to
to deduct this from this. What is like the relation between doing a mod of the same P, which is the number of, and it's like relation between sum and product.
I don't know. I think we have to give up for today. I don't know, maybe next time.
Can we check it? What is the
I have a feeling that there's something that might be possible here. If we're not working with these divisions, because we only care about the 3's, and if we don't have to divide by 3 every time, if we can convert n from the beginning to something that we know has some relation to all of these 3's.
Yes. That's why want like to reduce it as much as possible. For example, if we know that this NF would be written as like power of something, so we can just reduce.
For example, if we knew the largest prime factor in n, then rather than starting with the division by 61, we would start with the division by that factor. So in other words, we would start with the big ass prime factor here, remove all of this, and then all we have to do is divide that number by 3, I guess. You know, if we know all of the prime factors except for the 3, or actually we don't have to know all the prime factors, we just have to know, we have to start from the larger, I guess. So we could start by, let's see, yeah, we could just divide by 2 and just decrement until we, I don't know, how do you find the largest? Is there an easy way to find the largest prime factor of a number? A quick way? Or we not?
Yeah, that would solve the essay.
The question answered itself, as I said. Okay, no, then that's not a very viable approach to make this smaller. Well, but yeah, you could try a little ground. So I don't know. You could pick some. This is a highly composite number, isn't it? Right? It's a factorial, of course. It's a fact. Well,
even this empty, like 3 to the power of empty, is, you said we calculate NF, it's large enough. So
well, actually, it's not the fact. We don't have the factorial.
we have the NF, like the 3 to the power of that big number, so this one would be super big.
Yeah, this is already optimized for not calculating the factorial.
Yeah.
You know? You want to say something? I think someday somebody's going to be watching this video and is going to be screaming that yes. Yeah.
It's the end of the day.
Yeah.
I think at least we still have an optimization issue, not we didn't come up to it.
Well, I don't know. You know,
Well, at least we have a try for the example.
Yeah. I think the only way we can actually get it more optimized is by figuring out some deeper thing about this. It's not just optimization in a sense that, I don't know, I put a type here or something.
Yeah.
Okay, but
I imagine if we do it the old way, like calculating the
Yeah.
loop through every
Yeah, this is good. Maybe John will be here next time and we can continue with this one. Okay.